Okay, guys, so welcome back. Welcome to those at home, welcome to those in person. Hopefully today goes all right. It will be a little different. Hopefully all the technology stuff works. So yeah, welcome back. It is very refreshing to see people actually in my classroom. I'll say that. That's pretty nice. Hopefully your first period class went well, and that things weren't totally awkward. And if they were, well, hopefully it gets better. But we're going to get started. So today we're going to be doing practice problems from section 10.1 dealing with comparing two proportions. To do this, we're going to I'm going to try and use breakout rooms-ish, kind of. It didn't really work out that great for first period. I got an idea of how to fix it a little bit, so we'll see if that works. Maybe it will, maybe it won't. We'll find out. But to start, I am going to put a link in the chat to a document so that you guys can get a copy of this Google document that has the problems on it and links to some resources. So I need to do this, I think. If this works. Hopefully I've done this properly and this will make you make a copy of this document. Please tell me if it doesn't, because that means I did something horribly wrong and we'll all be on the same document. We'll see. So I'll give you all just a minute there to get that document going. And then I'm going to do this. Excellent. All right, and so this is what the document should look like. That's a little too big. Go there, perfect. And we're gonna share my screen so you guys know what this looks like if you're still pulling it up and you're not sure if you've got it. Screen 3, there we go. Awesome. All right, so this is what the screen should look like. All right, this is a document. You should be making a copy of this document and hopefully that worked. Those of you here in person, did it work? Did it make you make a copy? Yes. All right, cool. Excellent. Technology is cooperating for a little bit here. That's awesome. All right, so stupendous. So this is our document. All right, it is got the practice problems on there. We will be working with some groups stuff here today. I want to give you guys a first like 5 minutes here just to look over the questions. Kind of get yourself organized. Think of methods, think of things you're going to need. All right, at the beginning of this document, notice I've got a note here about the 4-step process. All right, many of you have not been properly using the 4-step process yet, and that's partially my fault because I haven't been pressing it enough, and it's partially just wanting to do the math and get the answer. All right, so the 4-step process is a must. Anytime you're asked to perform inference, construct and interpret, like a confidence interval, carry out a significance test, right? When you see verbiage like that, when you're asked like, is there sufficient evidence for this, use the 4-step process. State, plan, do, conclude. The process allows you to stay organized, right? And it's the specific things that the graders, the AP exam graders, are looking for stepwise. They want you to have these things present in your answer. If all you do is provide a calculation and a circled answer, you will not get a passing grade. Even if your answer is correct, you're missing too much of the other stuff, the explanation, showing that you understand what this is. Right, that's what statistics is. You need to be able to use that value. What does that value mean? Right, if you're simply just providing a number, I'm glad you can find the number. That's part of the process, but it is not the solution. Okay, so we have to keep that in mind. So I'm stressing this now, the 4-step process, we've got to use it. All right. Right here, we have a link here to the study guide for section 10.1. Right, this takes you back into Canvas. That's where the study guide lives. That's where I have it posted. It's a PDF. It has formulas and examples from section 10.1. So if you're trying to figure out how to use some of these things, that's a good go-to spot. Right? And you can access the AP exam formulas and tables here. Again, this is something you want to start familiarizing yourself with. What are the formulas that are on here? Right? This has your table A, your table B. It has another table on there that we haven't used yet. Right? You want to start familiarizing yourself with this resource because it's what you're going to have access to. Okay? And then we get into our questions. There are 4 questions. Right? They all have multiple parts and they're all word problems because everything we do is a word problem in statistics. All right, so there are multiple parts here. All right, when you're writing your solutions or inputting your solutions, you can take pictures and put them in here, right? It's a Google document. You can do anything you want to do that you've done previously with Google Documents. You can do that here, right? You can write math in the Google document. Right? If you go to Insert, Equation, all right, you get this little set of tools here. You can type math into this space. If you want to have something that's typed math, all right, that is an option. All right, and so this is where we're going to start. Again, I want to give you just 5 minutes to look over the document, look at the problems, kind of strategize. I'm going to organize groups for the breakout rooms so you guys can work together. Those of you who are here in person, I'm going to try to have you guys in groups that are with people who are here in person. So to help me do that, could you, if you're here in person, obviously, click the little raise your hand icon because I honestly don't know the names and faces that go together yet. So this is going to help me organize myself so I can get the groups properly set up. Leave your hand raised for the time being until I ask you guys to lower them. And we're going to do 5 minutes here. And then we will hopefully be able to get started. Hopefully. Ready, everybody? So that was our 30 minutes. I know that it may or may not have gone by fast for you. And I know that it wasn't enough time to do all 4 questions. All right. That being said, I'm kind of giving you this time limit just as a simulation, right? AP exam, you're going to have limited time, right? So learning how to use your time is part of that process. Obviously, this is not graded. I'm not expecting you to finish all of it. But I want you to have that kind of sense of time. How long is 30 minutes while you're working? Right? You're gonna have time limits imposed during the AP exam. You need to have a sense of how much time has passed and how long you've been working for so that you can pace yourself better. All right. So there's that. So we're going to go over a couple of the first 2 questions. I've got solutions written up for that we're going to go over. For those of you who are live in person, I saw a lot of you guys taking notes, like going into the study guide and looking at past presentations and taking notes, making flashcards, some of you. So I really liked seeing that. That's excellent. You're studying. That's awesome. I appreciate that effort. And I know that because you were doing that, you didn't do as much of the work, the problems. That's okay. Please don't worry about that. I like that you were taking the time to study and understand the content better. And I liked that you were using the resources available. That's always awesome. So we're going to look at some of these solutions here. So give me just a moment. I'm going to pull this stuff up and share my screen. We'll talk about these things. And I think perfect. All right, so let's do this and that one. Perfect. Awesome. Okay. And we're gonna do So again, I'm on a shared screen in here. Actually, I messed this up. Give me a second. I want this over here because that makes a little more sense. Perfect. Now I'll share my screen. That makes more sense. All right, so on the shared screen here, if you guys are live in person, you can kind of see it. I know it's not terribly dark, unfortunately, just because of lighting. For this first question, at the top here, I've actually listed, I've shown the necessary information from the context, right? We have our populations, child and adult mix, the proportions for the population. Right, we have our parameter proportions here, and then we have the sample sizes. Please note that the sample sizes are different. The sample we took from the children's population is 50 jelly beans, and the sample from the adult is 100. They are not the same. Okay. Then the first question here, we need to check the normality, so to say, right? What's the shape? Right, this distribution of p hat sub c minus p hat sub a, that's the notation I use. If you used p1 and p2, perfectly fine. I gave the parameters as being p sub c and p sub a. All right. So the difference between the sample proportions will be approximately normal because, well, this math, the number of successes and number of failures for each is at least 10. Essentially, that is our large counts condition. The large counts condition allows us to have a normal shape, a normal distribution, right? So we have 15, 35, 15, and 85, all at least 10. So we're good. All right. Part B, what is the mean of the sampling distribution? So the mean of the difference of the sample proportions is equal to the population proportions. The difference between the population proportions is 0.3 minus 0.15. We get 0.15. And that is the mean. And this follows from Chapter 6, Principles about Random Variables. And then for Part C, the standard deviation of the sampling, the difference of the sample proportions, blah, blah, blah. We get this crazy big square root. And when we substitute in our values, we get the square root of 0.3 times 0.7 divided by 50 plus 0.15 times 0.85 divided by 100. And then we get this decimal 0.07399. I chose to round it to that. If you choose to round it to 0.074, that's fine, 0.0739. You know, however you're rounding it, as long as you're showing this, the big square root with all the proper values in it, however you round this doesn't really matter as much because you've shown the math and the numbers properly here in the square root. Right? That shows the reader, the grader, whoever, that you understand how that number is attained, which is the bigger part of this. All right, so that is question 1. Is there any questions? Is there anything I can clarify for question 1? Okay. So then we'll look on to question 2, which, give me a second, I gotta fold this thing here. All right. So once again, the very top here is not part of my solution. It's not part of answering part A. Notice that it's before part A. This is just the values and things that I'm using, the stuff that I need from the context. Right? Population 1, I'm identifying as the men's population in this study. Population 2 is women. Sample size 1 was 2,253. Sample size 2 is 2,629. Right? The sample proportion for the men, or P1, was 0.4376. Then the sample proportion 2, the one for women, is 0.3511. So now I have those values. I do not need to go back into the word problem to find them. That's the main reason I do this. It's organized. I'm doing it before doing any other calculations. It allows me to stay organized and not lose which value or make a like a dyslexic error, so to say, where I transpose the numbers later on. All right. Then question A is our 4-step process. We've been asked to construct and interpret a confidence interval. So we're starting with our statement. All right. We want to estimate the parameter P1 minus P2, the difference between the proportions, where P1 is the true proportion of men living at home and P2 is the true proportion of young women living at home at a 99% confidence interval, or confidence level, sorry. All right, so that's our statement. We've now told the reader the parameters that we're using, P1, P2, what they mean, and what we're going to do. We want a confidence interval, and we're trying to estimate that value with a confidence interval. So then we move on to the planning step. If conditions are met, we will use a 2-sample Z interval for P1 minus P2 for the difference of the population proportions. All right. Typically, the Z statistic will be used for proportions, while the T statistic is used for means. There's a major difference. If you use a Z statistic or a Z method of inference, when you're dealing with means, that's going to be wrong. You're going to get a slightly incorrect answer because it's a different estimation method. It's a different inference method. Right, with proportions, we're using a 2-sample Z interval. That's our inference method here. Random, we were told in the context that the samples are random. 10%, all right? And this is a little different than you've seen before, than the way that I've done this previously. There are more than 22,530 young men and 26,290 young women in the US. All I did there is I multiplied the sample sizes by 10. Right? It is obvious that there is more than that amount of young men and young women in the United States. Right? Since there's more than that, the sample size is less than 10%. Because if there was exactly that many, the sample size would be exactly 10%. We know that the population is greater than that. So it's another way of saying that the 10% condition is met without, like, we obviously don't know the actual population size for young men and young women. We weren't given that. Lastly, we have our large counts. Right? The number of successes and failures in both samples is at least 10. In this, I'm being a little lazy on this answer. We should probably be more specific, but based on our proportion up here, we have 986 successes and 923 successes and over 2,000 sample sizes, right? So we have at least 1,500 failures in each case, give or take, right? Just as a round estimate. So it's very easy to see with our samples that we have more than 10 of each case. So I'm just making that statement. Lastly, we do the math. Right, a 99% confidence interval results in 1% left over for the two tails, which means one tail is 0.005 as a decimal, which results in a Z score from table A of negative 2.575, which gives us a Z star, a critical value of 2.575, because remember we just used the positive version of whatever we find from table A for the Z star value. We could use the negative number if we wanted, and we would technically get the same results. Positive numbers are just easier to deal with. Then we do our interval, and we have our massive calculation here. This is all the notation that goes into it. We get the results of 0.08655 plus or minus 2.575 times 0.013996. which gives us the interval 0.051, 0.123. All right. It is correct to write your interval with the smaller value first. You should never write the larger value first. Intervals are properly written with the lower bound first and the upper bound second. If you write 0.123, 0.051, it's technically incorrect, even though you found the right values. All right. Intervals go from small to large. Is there any questions between the plan and do steps here? Anything I can clarify? So then lastly, we get our conclusion here. All right, we are 99% confident that the true difference of proportions, P1 minus P2, of young men and young women who still live at home is captured between the interval 0.051 and 0.123. That's our conclusion. We've tied our results back to our original context. We're good. Last part here, part B, since the interval does not contain 0, there is convincing evidence that the true proportion of young people who live at home is different for men and women. Right? This is answering the question that was asked. The question asked was, is there a difference between the proportions of men living at home and women living at home? The answer to that question is yes, and this is why. We were not asked, are there more men living at home than women, or are there more women living at home than men? That was not the question asked. So you don't need to say anything about that. Saying something about that just opens the door for them marking you off points for something you weren't asked about. All right, answer the question being asked. Is there a difference? Yeah, our evidence says there's a difference. All right. Is there anything I can clarify? Anything I can explain in better detail? All right. We are going to stop here because we're just over an hour here, and I think that's enough. With these examples, you'll have access to this. Obviously, you have a copy of this document. You have the problems. I will post all the solutions at the end of the week because I got to use this again on Thursday with the classes I haven't seen yet, and tomorrow with the classes that, well, not tomorrow, but my second period class on Thursday. They haven't seen this yet, so I'll post it after that class. You'll have access to all the solutions if you need those. The questions here are very similar to the practice problems and solutions in Canvas for section 10.1. Okay, so if you want other problems that are similar, there's other practice problems there. I'm gonna stop sharing my screen. Also, okay, one thing that I mentioned to the students here that were here live in person, if you have your graphing calculator, you need to start practicing with it, especially if you're taking the AP exam. That TI-84 graphing calculator that you have is the one that you're going to be able to use. Right? You need to be familiar with how it works. You need to be familiar with how to get it to do the things you want it to do. If you do not have access to it, I recommend using the Desmos graphing calculator because it's kind of easier to use than other calculators that are online. You can just type stuff in the way that it looks and it will show you the answer. So it's kind of useful in that way. Other than that, we'll be looking at some practice stuff for 10.2 tomorrow. And after tomorrow's class, I'll probably decide on what I want to do, whether or not we're ready to move on from chapter 10 or if we want to spend a little more time with it. I'll figure that out myself based on what I'm seeing. And then, yeah, that's it for today, guys. I hope you guys have a great rest of your day, and we'll see some of you guys live tomorrow. But have a great day.